Exploring rainbows with CFHT's instrument called ESPaDOnS. CFHT stands for Canada-France-Hawaii Telescope. That's an observatory which is located near the summit of Mauna Kea on the Big Island of Hawaii. This picture of the inside of the dome shows you the telescope. It has a primary mirror of a diameter of 3.6 meters. You'll notice some people working inside the dome. That gives you an idea of the scale. That's ESPaDOnS. ESPaDOnS has two parts. There's a section which is installed under the primary mirror of the telescope. And a couple of floors down, there's a white box that has various optics. That's the part that we call the spectrograph. ESPaDOnS is a spectral polarimeter. Spectral polarimetry combines two techniques, spectroscopy and polarimetry. When somebody is doing spectroscopy, they simply decompose the light of the object they're observing into its different wavelengths or colors using a prism, for example. When we do polarimetry, we get more details, the characteristics of the light as it propagates through space. At left, you see what we get out of the telescope with ESPaDOnS. That's a raw image. With some processing using specialized software, we can have a graph of the intensity of light for different wavelengths or different colors. And you'll notice that there are some high peaks and then some dips in that plot. What can astronomers do with those bumps and dips? What does ESPaDOnS do? If we do spectroscopy, we can figure out the temperature of a star, its age, its composition. If it's a binary star, what is its mass? If we do spectral polarimetry, we can get into more details. For example, if a star has a magnetic field, we can see how strong the magnetic field is and what is its configuration. We can even figure out if a star has bright or dark spots at its surface. Here's an example. That's a simulation of a star that has dark spots. And as the star rotates in front of us, the dips, the features in the spectrum that we see in the data, the shape will change as a function of time as we study the star every night. And we can use those changes to figure out where are the spots and how big they are. We can do something similar for magnetic fields. We can figure out how many loops there are that go from one area of the star to another. And we can, in this way, figure out the configuration of a magnetic field and also the strength. That's what ESPaDOnS can do. It studies stars using rainbows.